begin with the properties of the sine function. So, as you guys can see, over here is our sine function. It has a period of 2 pi, which means one cycle lasts 2 pi units. So, it starts at the origin, which is over here, and ends at 2 pi. So, one cycle is gonna look like this. For the sine function, it goes up, goes down, hits the minimum point, which is -1 over here, and it goes back up to the point 2 pi, which is where one cycle completes. So this is what the generic sine function looks like. And a generic sine function has the equation of y is equal to sine of theta. So, or sine of x works as well. This is the generic function of sine. And it has an amplitude of 1, which means it goes up and down 1 point from the midline. So if our midline is at y is equal to 0, which is the x-axis, it goes up 1 point like this, and we get y is equal to 1. And if we go down 1 point from the midline, our y value goes to -1. Okay, and for our domain of the function y is equal to sine x, it extends all the way from -infinity to +infinity. If you just keep continuing this graph like this, it just goes on to -infinity. Same thing here, just continue the graph, it goes to +infinity, which is why the domain goes from -infinity to +infinity. And for our range, it's just the maximum and minimum points of the function. So if we have an amplitude of 1, our maximum and minimum points are 1 with 0 as the midline. So that's gonna be our range because our y value does not extend above 1 and -1. So our graph doesn't go above or goes below a -1 like this. So that is why -1 and 1 are the maximum and minimum values, which is the range of the function. And if you guys are wondering if we use brackets or parentheses for the domain or range, for the range we have to use the brackets, which is this, because the graph touches the points 1 and -1, basically touches the range, which means it's included in the y values. But if we use parentheses, it is when the graph is approaching that value but doesn't actually touch it. So we cannot say that our graph touches -infinity or +infinity because infinity isn't a value, it's just a concept of of how much a number stretches in the negative or positive direction. So if you guys are wondering if we use brackets or parentheses, then that's the explanation. And for our symmetry of the function y is equal to sine of x, it is with the respect to the origin because sine of x is an odd function and the graph is symmetrical dia diagonally. So this is what it looks like. So hold on. With respect to the origin, so we put a point here. Okay, let me get a darker color. With respect to the origin means it's diagonally symmetrical. So like the points are like this. No, it's diagonally symmetrical, and I'll show how it is. I'll show the other way it's symmetrical with the y is equal to cosine function. So let's move on to the properties of the cosine function. So just like the sine function, the equation is y is equal to cosine of x. It has a period of 2 pi, but instead of the intercepts being at the midpoint, which for the sine function is like this, for the cosine function naman, it goes from peak to peak, just like this. This is how you calculate one oh, one period of the cycle. Okay. Um, Hold on, guys. Okay, my bad. My drawing tablet died. So this is how you calculate one cycle of the cosine function, and the midpoint is just the center between the ending point and the starting point. So for the generic cosine function, the starting point is at 0 and ending points at 2 pi for one cycle. So 0 plus 2 pi is 2 pi divided by 2 is just pi. So our midpoint is just pi, which goes over to the minimum part of the function, which I'll be going over later. So just like the cosine function, it has an amplitude of 1. So it extends from 1 to negative 1 if the midpoint is at 0 or the y-axis. So for the domain, it also extends from negative infinity to positive infinity. So, just like the sine graph, it just extends all the way to negative infinity. Same thing here, goes to positive infinity. And same thing for the range, it's just the minimum and maximum values of your graph, which unless you change the amplitude, it's gonna be 1 and negative 1 for a generic graph. And for the symmetry, this time it's with respect to the y-axis, which means no, that the graph is just a reflection of it. So the side of the negative is just a reflection of the positive side. So as you see, this looks like this, and this looks like this as well. It's just a reflection, as you guys can see. This goes like this. Same thing with here, it's just a reflection, like goes the opposite way. So that's how you can tell how the graph is symmetrical. And the cosine function is an even function, which helps you with the symmetry as well. So now let's go over the amplitude of the sinusoidal functions. So for sinusoidal functions with the form of a sine b of x or y is equal to a cosine b of x, the amplitude is the absolute value of a, the period of the sinusoidal functions. And for sinusoidal functions with the form y is equal to a sine of b of x or y is equal to a times cosine b of x, the period is 2 pi over b, which the period means the how long one cycle